I'm Jackie with DMT Institute, and today we're going to talk about finding the area of a parallelogram. And to do this, we're actually going to relate back to finding the area of a rectangle because everything's kind of grounded in that. So again, hopefully we've had some earlier conversations with students about finding the area of a rectangle and focusing on those square units. If not, we had a little bit more conversation about this in the video on triangles. You could watch that as well. But what we're going to do is we're going to take a look at our parallelogram, and we're going to look at how can we take that area and decompose and recompose to find something that resembles a rectangle. So one of the things that we're going to do here is we're going to think about, oftentimes we tend to go to this vertex, and we start at the vertex and we could draw a line straight down, again forming those 90-degree angles. And again, the 90-degree angles are super important because we're trying to compose a rectangle. So I would think about taking this piece, and then I'm going to bring it over here. I'm just going to translate that over, and now I have that rectangle. So I can think about the area of I can take my base right here and multiply it by the height, which also happens to be the same height that I just used to decompose. Base times the height, and that's going to give me my area, my parallelogram. And the nice thing is that's really all I have to do, because this space, this part of the parallelogram, has already been accounted for when I translated it over here. So it's really just decomposing and recomposing. So it's still the same area, we've just made it look different. The nice thing about that parallelogram, again, because it's composed of two sets of parallel lines, that also helps us know that the length of this side is going to be the same as the length of this side. And that's going to stay the same every time because of those properties of two sets of parallel lines, which is why we're able to move that over and translate it every time and have it actually match up and create that rectangle. So I know one time I was doing this with students, and a student asked, well, do I have to decompose at the vertex? So I'm actually going to pose that back. So let's take a minute and think about that. So do I have to decompose at the vertex every time? Could I decompose in a different place? And if so, what are the things I have to think about? So maybe take a second, pause the video, explore that a little bit, and then we'll come back and talk through it. Okay, hopefully you had some time to explore. So what we ended up coming up with is that idea. We often see it, and if we look at our different resources, it tends to be at the vertex. Works every time. However, we could really take this and decompose it any place that we want. The big thing is that we've got to create those 90-degree angles. So as long as that's done, we can actually decompose in multiple places. So now when I was working with that student that I mentioned, I could actually take it right here and decompose right there if I wanted to. As long as I'm still seeing those 90-degree angles, it allows me to take one of those pieces and translate or slide it over. So I end up with that rectangle. So again, as long as I form those 90-degree angles, which goes back to what we've done with rectangles, we're able to still connect to that formula of base times height. So hopefully that was helpful for area of parallelograms. We'll see you next time.